So in this class, we'll spend some time on understanding the Arduino board again in a detailed manner. What are the important parts inside? Uh, um, because this is one board which we are going to make use of for our product designing. To give a quick glimpse of what we are trying to understand here, we saw the important components of electronic system designing. In that component pyramid, we have four components. At the top, we have the controller part. Okay. The second one is the programming part of this controller. The third is the sensor part. The fourth one is the peripheral part. So this is in your curriculum, four for this. One is for this. This takes another unit. This takes one full unit, and this takes one full unit. And in the fifth unit, you will integrate all and see how to design systems. So the first job is to understand the controller part, which is the top of the pyramid. That is what we are doing now. So what is this Arduino is all about? What are the important components of Arduino? What are the important precautions that you have to take as a designer is what we are doing now. So first of all, to start with our discussion, what is Arduino? All of you must be aware of this answer. And Arduino is an open source platform. Open source platform, which includes a piece of hardware and a piece of software. By using these two, you can design rapid products. This word product can be replaced by project if you are a hobbyist. Okay, if you are a serious person, then that word project is replaced by a product. But this board can be used for both. Okay, you have to understand very clearly the meaning of this open source means. The word open source means something which is available at free of cost without any license fees. What is this license fees? I'll tell you what is this. Somebody has invented this board. Okay, somebody has this is innovated by somebody. This board is an innovation of an individual. But that individual who has innovated this board has given this board as an open source board. Open source board means what? Somebody can take my innovation, they can reuse it, design products and sell. You need not have to pay any license fees. That is what it means by open source. Open source means you can take the innovation of somebody, reuse that particular innovation, remodify it, and then you can sell it or you can use it for your own purpose without having to pay any license fees for that particular individual. License fees means what? If it is not made as an open source, then it is mandatory for any individual to pay a small amount of money to the innovator as a license fees in order to use his innovation. That is law. Okay, as per law, if you want to use the innovation of somebody, okay, it is necessary that you have to, it is your obligation that you have to pay that particular individual a small portion of your profit or a small, license fees in order to use the innovation of some individual. But in this case, since it is license, you need not have to pay any license fees since it is available as an open source. You are free to use this board, and you can free to use means this board is not available at free of cost. Free to use means the design of this board is available at an open source mode. That's what we mean by that. Okay, free to use the design of the board, not the board itself. Board, of course, you need to buy by paying a small amount. The design of the board is available at open source mode, which means you can reuse that particular design and then you can redistribute it. That's what it means. An Arduino is an open source hardware plus software platform that is used for rapid product development. So what I do, I take this board, number one, and I add intelligence to this chip by virtue of developing a small program. And I combine these items 1 and 2, and I develop a product to an individual at shortest possible time. That is what we mean by rapid product development. The word rapid means something which I do at very fast time. Okay, so conventionally, when you are designing products, electronic products, it used to take a very long time. We need to validate a lot of things in a breadboard. Of course, we do use breadboards in this case also, but not to the micro level, only at the macro level, like interfacing some external peripheral devices, interfacing an LCD device, and then doing some peripheral interfacing. For all those things only we need. Otherwise, it is not necessary for you to connect anything. So using this board, you can develop an electronic product the shortest possible time. All of you are with me? The topic of today's discussion is what is inside this Arduino board. Okay, so there are two components here. One is the hardware component, the other one is the software component. The first one, we will spend some time on understanding what is this hardware component, number one. Okay, so that's what it is. If you see what is inside this Arduino hardware, okay, there are wide number of electronic components which are present in this board. The board size is typically half the size of your smartphone. You can imagine what is the size of this, though it is looking bigger here. In actual case, the actual size, if you see, it will be half the size of your smartphone. So it is relatively a small sized board. Okay, so we'll understand and see what is inside this Arduino hardware and understand the important basics. Later, by the end of this course, I'll teach you how to design your own board. Okay, later on, I'll teach you how to design your own board by the end of this course. As of now, you pay your attention to the extent of how to use this board. So in stage one, we will see how to use this board first and design products. Later on, you convert your idea and then you pay attention on how to design such a board. Okay, it is also possible for you to design such a board. In the last video that you watched in the presentation that I shared you on the day, you would have seen a small Arduino board that is developed by us in the incubation center. So which means it is possible for you to design your own Arduino board with customized requirements. So that is a much involved thing. We will discuss about that later. As of now, our focus is to know how to use this board and come up with a lot of interesting products. Okay, so that is our focus. Right, in that particular video that I shared you, I would have given you a small example of what is the analogy of this particular board. Okay, so you can imagine this particular board as a Aladdin's lamp, Aladdin's magic lamp. So you can take this particular thing as your Aladdin's magic lamp, and the moment you rub this particular lamp, the genie will come out. Okay, a genie is a powerful slave. That particular slave will do lot of powerful, it will fulfill almost all your wishes. That is what a genie does. It is a slave. So what is a property of a slave? Okay. The property of slave is it is very powerful. It can fulfill all your wishes. Okay. It will fulfill all your wishes. It's so powerful that it is capable of fulfilling all your wishes. Similarly, if you compare here, this complete board is your Aladdin's magic lamp. What is the equivalent of rubbing this lamp? The equivalent of rubbing this lamp is powering this board. How do I power this board? I either power this board by using a power adapter, just like you power your mobile phones using a separate adapter, or I can use a small USB cable and connect this particular device to a personal computer or any USB host device. Either ways you can power. So the moment you power this board, the genie that is present inside this lamp will come out. So who is the genie of this particular board? Here is the genie. This genie is called, a microcontroller. This genie, what I am showing here, is called a microcontroller. This microcontroller is the genie that is present inside this magic lamp. This genie will come out once you power this board. This is the genie here. You understand? Such a genie is a slave device. That is what I am trying to understand here. What is the first property of a slave? A slave is so powerful that it is capable of fulfilling almost all your wishes. This microcontroller that is sitting inside this particular board is so powerful that it will enable you to do majority, I cannot say all, majority of your real-time applications. You can build lots and lots of powerful applications. Obviously, if the capacity of this genie is not up to the mark, we can always substitute this genie with a larger genie, which can do the job. But almost all the genies are equivalent in terms of how they work. Meaning, this Arduino board is one version of the board that we are discussing. There are lot many different Arduino boards are available. All of them work in the same way. In case if the performance of one Arduino board is not up to the mark for your project, we can always substitute that with a highly powerful Arduino board which suits your requirement. That's what it is. So this genie present inside this magic lamp is very powerful. Number one. The second important property of a slave device is it cannot think on its own. This is the second property of a slave. The genie that comes out of this lamp is so powerful that it can almost fulfill whatever you ask for. But what is the problem here? The problem is you should know how to communicate to the genie and you have to tell the genie what exactly you are looking for. Okay? Because the genie is a dummy fellow. We cannot understand or think on its own. Okay, so he never do things on his own. Somebody has to instruct him. Somebody has to clearly tell him what exact job that fellow has to do. More importantly, the third important property of this particular slave, what we are dealing here, is this fellow doesn't understand your language. Okay, the language that I am very comfortable with is Tamil. Next to that is English. In either of these two languages, if I communicate to this genie, do this or do that or in whatever way I want, this genie cannot do anything because it is something that that fellow doesn't know. So what is a language that this genie can understand? This genie can understand only zeros and ones, binary language. It can either 0 means false, 1 means true. The other way of telling the same thing is 1 means yes, 0 means no. So it can either answer yes, no, true, false, or 0, 1. Only in these two possible states, this genie can answer or accept instructions. It is applicable both ways. This genie can understand zeros and ones. It can also give you the answer in the same zeros and ones, which is something which we are not very comfortable with. So these are the three important characteristics of this slave device that you have to understand. First one, it is very powerful, extremely powerful, capable of fulfilling almost all your wishes. Coming back to our electronic device, this Arduino board is so powerful that will help you to perform lots and lots of powerful projects in no time. Okay, that is the equivalent of that. Second point, this genie is a dummy fellow. He cannot think on its own. Though he is very powerful, he is not smart. It is necessary that the master of the genie has to give instructions to that slave. Coming back to this board, this microcontroller, which is the genie for me, is very powerful, but it cannot perform anything on its own unless I give instructions to that particular microcontroller so as to what it has to do. Third important characteristic of the slave is it cannot understand the natural language that we speak. Coming back, it can understand only zeros and ones, yes or no. If you ask something to the genie, yes or no is the only answer it can give. Similarly, it will also accept commands of what it has to do in the same yes and no format. Okay, so that is called binary language. In this language only, you are supposed to give instructions to the genie. Similar thing is applicable to this microcontroller. This microcontroller can understand only zeros and ones, binary language. So if you are planning to tell this microcontroller to do certain activity in your own language, which you are very comfortable with, then there is a communication gap between you and this microcontroller. And naturally, you need to have a middleman between you and the microcontroller. If you remember in your childhood days, 10 or typically 10 to 15 years back, you know, if the Indian Prime Minister makes a visit to Arabian countries, he always take a translator with him. Okay, because the Arabian kings or the Arabian, uh, bureaucrats on the other side doesn't understand English. Nowadays they speak English fluently, but in those days, whenever a bureaucrat or a prime minister or any higher official who is visiting to an Arabian country, they always take a translator along with them. So, what is the job of this translator? The job of the translator is to so I'll just draw a small diagram here on the left hand side. Here is the Indian Prime Minister. Here is the Arabian Prime Minister. The translator actually sits in between the two. Even in television, news, if you see, the translator used to appear in between these two prime ministers. Very often we used to wonder what this fellow is doing there. The job of this translator is to take the inputs from the Indian Prime Minister and give in the format that the the Arabian Prime Minister can understand, Arabian King or whoever it is, which means he takes the instructions in English or Hindi from the Indian Prime Minister and he communicates and translates that in Arabic or whatever the language that the other counterpart can understand. This translation is necessary. Otherwise, whatever the Indian Prime Minister is speaking, the Arabian counterpart cannot understand. So there is a communication gap between the two. So similarly, just like Indian Prime Minister, I am the master here. Just like Arabian Prime Minister, here is the microcontroller device. Okay. The language that this particular device can understand is only 0 or 1. But I am comfortable with my own language. Okay. Which I cannot communicate. Whatever the language that I speak, that this particular programming language is not capable of understanding. So naturally, I need to have a translator in between. What is the job of this translator? this translator take the instructions from me and translate into zeros and ones that this particular microcontroller can understand. So what is the name of this translator? The name of this translator is called compiler. What is the job of this compiler? The job of this compiler is to take the instructions from the designer, which is me, and translate into zeros and ones, which the uh, microcontroller can understand. That is the job. Why that is necessary? Because the microcontroller, which is a slave device, cannot understand my language. So these are the important three concepts that you have to understand about your slave. My slave is very powerful, but my slave is a dummy because it cannot think on its own. So if he wanted to perform certain things, I have to instruct him. How can I instruct him? He cannot understand my language. Then I have to appoint a translator which can translate the instructions given by me into zeros and ones, which the slave can understand. So that is something that you have to understand. All of you are with me so far? Now let us go deep into what is available in this board. Let us spend some time in understanding our slave device because it is the slave device which matters more for us. Understanding your slave. So the slave that is sitting inside our board is called a microcontroller. So what is a microcontroller? A microcontroller is naturally a programmable IC. What is a programmable IC means? Programmable IC means I can define the functionality of the IC by writing a small program. By writing a small piece of code or program, I define the functionality of the IC. What do you mean by functionality? What job this IC has to do? Let us take a small IC that many of you must be aware of. A small 7400 IC. 7400 IC, if you take, this IC is called quad NAND gate. If you don't know what it is, you know what is a NAND gate, right? A NAND gate takes two inputs and it gives you one output. X, Y is the input. Z is the NAND output of X and Y. X, NAND, Y. So this IC 7400 has four such NAND gates. So it takes two inputs and it gives you one output. And it takes again another two inputs and it gives you one output. Similarly, four such NAND gates and one power supply pin and one ground pin. So this is a small IC. In this quad NAND gate, if you give inputs X and Y here, Z will be the NAND output of X and Y. So this is called a fixed function IC. Why it is called fixed function IC? The functionality of the IC cannot be changed. It is always going to do only one thing. What is that? It performs the NAND operation of the two inputs. Okay, this is called a fixed function IC. Whereas microcontroller is a programmable IC. What do you mean by programmable IC means? This IC doesn't have any specific function. The functionality of that particular IC is defined by the program that is written by the designer. What is the advantage? Today I define some function. Tomorrow I do some other function. Day after tomorrow I do some other function. So day in and day after I can use the same IC for performing multiple functionalities by virtue of changing the code. So that is more powerful than a fixed function IC. Okay, so this is a much powerful IC. So a microcontroller is such a programmable IC which can help you to define the function or what exact job that this IC has to do by virtue of developing a small program. And that program we call it as code. Okay. So such a programmable IC is available inside this Arduino board. The version of the Arduino board that we are using is Arduino Uno. You can see this Arduino Uno. So in this Arduino, we have one powerful microcontroller, and the name of that particular microcontroller is ATMEGA 328. ATMEGA 328 is the serial number of this particular IC. Okay, you can see the name of this, ATMEGA 328. Similarly, it is also available here. Okay, you can wonder why this IC is available in a long tubular format like this, whereas it is available in square sized shape. What is the difference between the two? The difference between the two is they are available in different packages. We use a technical term called packages. A package defines the physical shape of an IC and how the pins are available in that particular IC. The name of this package is called Dual Inline Package, DIP package. DIP package is very convenient for us to use in breadboards, printed circuit boards which has only one copper layer. So this is a DIP board actually. DIP board means the ICs have pins which can penetrate your breadboard, and you can insert in a breadboard and you can easily remove them. So you have totally 28 pins here, 14 pins on one side and 14 pins on the other side. This package is called QFP, Quad Flat Package. This package is used for designing printed circuit boards with extremely small size. Okay, when size matters, because the size of this IC can be very compact, and you can design boards with very small size, physical size. So when your size matters, then we go for quad flat package. If size is not a constraint for you, then your convenience is the matter, then we go for DIP package. But eventually, both these ICs perform the same functionality only. Okay, so there is no difference in terms of their functionality, but they are available in different forms. Okay, you can just imagine that this fellow is a boy and this fellow is a girl, and eventually they do the same job when it comes to taking a course in an engineering institute. So they are available in different forms, but eventually they do the same job in terms of their functionality. So that's what it is. So what have you understood here so far in this slide? In this slide, the heart of this particular board is a microcontroller device. The microcontroller is the slave which I am trying to gain control over. What is a microcontroller? A microcontroller is a programmable IC. What do you mean by a programmable IC means? A programmable IC means the functionality. Functionality means what is the job of the IC is not fixed by the manufacturer. It is fixed by the user of the IC. How the user of the IC defines the functionality of the IC? By virtue of developing a small program. So by virtue of writing a small code or program, I define the functionality of the IC. How it is different from fixed function ICs? Fixed functional ICs always do only one job throughout their lifetime. They can never change their functionality. For example, if you take the 7400 Nand gate, this particular IC will only perform Nand operation throughout its lifetime, and it cannot do any other job. Whereas if you take a microcontroller IC, today it do some job, tomorrow the same microcontroller can be used for some other job, day after tomorrow it can be used for something else by reprogramming it. Okay, it is only a matter of changing the program. So such microcontrollers are very versatile and very convenient for us to design products. That is why we use them. Okay, so a programmable device which can alter its functionality by taking a different code is a microcontroller. So what exact microcontroller we are using? ATMEGA328. Who is the manufacturer of that IC? The manufacturer of that IC is ATMEL Semiconductors. ATMEL Semiconductors. It is also reflected in the IC name, ATMEL Semiconductor. ATMEL, unfortunately, has been purchased by Microchip now. So Microchip owns the proprietary right of this IC as on today. But ATMEL is the original manufacturer of this IC, but ATMEL has been purchased by Microchip. Okay, so for clear. Next, you have to understand what are the important features of my slave device, ATMEGA 328 microcontroller. Okay, what are the important features available inside my slave device? So, what is my features of the slave device? So, this slave device consists of 28 pins. So, that is the first feature. 28 pin, 14 on one side and 14 on the other side. So, if you take any IC, on top you will be having a small groove. So, the left of this groove, you will have a small dot like a dot that signifies pin number 1. Pin number 1, pin number 2, pin number 3, etc. etc. Pin number 14. And the numbering starts from the bottom to top again. So 15, 16, 17, 18, and it ends at 28. So when you number an IC, top left is normally the pin number 1. Okay, so you start counting the IC from top left and it goes from bottom to top again. So that is how we have to count the IC. So you have 14 pins on the left hand side and 14 pins on the right hand side, totally 28 pins. That is the first specification. Second specification, it is having a flash memory of 32 KB. So as I told you in the previous class, this is equivalent to your hard disk. So this is nothing less than a microcomputer. So what is the hard disk size of your microcomputer? 32 KB. What is the job of this particular thing? This is where we put our source code. This is where I put my source code. More importantly, this is non-volatile. What is non-volatile means? Whatever the program that I put inside this code memory permanently resides inside the microcontroller even when we put off the power. That is what we mean by non-volatile. Some contents, whatever a memory is non-volatile if and only if the memory is capable of retaining the contents even when the power goes off. That is what we mean by non-volatile memory. This is a non-volatile memory. All of you are clear? Why it has to be non-volatile? What will happen if it is a volatile memory? Suppose, for example, I am designing a washing machine. So I put the source code of what is this functionality of the washing machine inside the microcontroller of the washing machine, and I ship the product to the customer. Do you expect the customer to turn the washing machine on throughout its lifetime? Because once if you put off the power, whatever the content that you have written inside the microcontroller will evaporate and it will be blank. Next time when you boot the washing machine doesn't know what to do because the microcontroller doesn't know because the program is gone already. So you cannot put your source code into a volatile memory because the program is the one which acts as the brain of any device. If I want a washing machine to perform washing operation, the program memory or the code memory should be non-volatile so that whatever the instructions that I store inside the program memory remains permanently. So that is what is more important. The second type of memory is the RAM. What is the size of this RAM? 2 KB. We are not talking about GBs or TBs. We are talking in terms of not even MBs. We are talking in terms of KBs. They are extremely small sized devices. So what is RAM? RAM is used for storing data. This is a data memory. Flash memory is code memory. RAM is data memory. So what is the purpose of this data memory? To save and retrieve temporary data. This is volatile in nature. Okay, so 2 KB. There is an intermediate EEPROM device that takes the advantages of both. So 1 KB of EEPROM is available that takes the advantages of these two types of memory. It is non-volatile like your ROM. It is also read-write compatible like your RAM. In RAM, you can perform both read as well as write. Whereas here, you can only write, you can only read. You cannot write contents into, you cannot write contents on the runtime. When the microcontroller is performing certain operations, you cannot write some value into that code memory. Okay, you can only read instructions from it. Okay, so this is that is why it is called read-only memory, ROM. This is called RAM or random access memory because you can both read as well as write. So it takes the advantages of both versions of memory. Okay, so I'll clearly write it here for your understanding. ROM is volatile, non-volatile, but you can only read values from it. RAM is volatile, but you can read as well as write into this device. The name of ROM is called code memory or program memory. The name of RAM is called data memory. This is a beautiful feature. I can put contents permanently, but I can only read values from this. Here, this is volatile in nature because once I put off the power, contents will evaporate. This is a beautiful feature. I can read and write whenever I want. So there is one memory which takes the advantages of the two. Non-volatile feature of ROM and the read-write feature of RAM. Such a memory is called EEPROM device. Electrically erasable, programmable read-only memory. Okay, so there is one memory which takes the advantages of both RAM and RAM, that ROM and RAM, that is EEPROM memory. So that is 1 KB available. Number of I/O pins, 23 pins are available, but Arduino uses 14 pins for digital and 6 pins for analog. So totally 20 pins are used. 3 pins are used for different purpose. So I/O pins of microcontroller is 23, out of which Arduino or the board uses only 20 of them. It has timers. Timers are like your wristwatches. So why do I use my wristwatch? I use my wristwatch to manage my time. So I schedule my activities accordingly. I have my class today. After this class, I have a meeting with principal. And then after this particular meeting, I have another meeting at 2 o'clock in the Google Meet platform. I need to go to the incubation center afterwards. So I actually schedule my activities and fix my activities in accordance with the time. So the wristwatch will help me to do that. So similarly, this microcontroller you can use to do time-based activity, and you can take control over time by using this timer. So this microcontroller has 2 wristwatches, and there is one analog to digital converter. This is a beautiful option. Because this microcontroller can understand only digital, it cannot take any analog inputs directly. So there is an analog to digital converter that is sitting inside the IC itself. So if you supply an analog signal from a sensor, that analog signal can be converted into digitally within the analog to digital converter that is present within the microcontroller itself. So you need not have to connect an external analog to digital converter IC. So there is a analog to digital converter that is present inside the IC itself. The job of this analog to digital converter is to convert analog signal to digital one. Okay. You have something called PWM. PWM stands for pulse width modulation. pulse width modulation. I'll teach you what is pulse width modulation later on. You see, there are 6 of them available. You have one RTC. PWM stands for pulse width modulation. RTC stands for real-time clock. Real-time clock means a clock which tells you time on real-time basis. What is the time now? What is the time now? 11 or 10:23. Oh, I'm extending my class beyond the scheduled time. That is fine. You have lost 10 minutes. So RTC means I know what is the real time value, what is the current time. So just like your wristwatch or your mobile phone shows, this microcontroller also has a real time component that is sitting inside that will tell you the real time value of the time. You have 2 communication protocols, SPI and I2C. These 2 are communication protocols where the microcontroller can communicate with any external device by using only 2 wires. So this microcontroller has the ability to speak to any slave device or any other external device by using only 2 wires. Okay, so this 2-wire communication protocol is called SPI and I2C. SPI is called serial peripheral interface, and I2C is called inter-integrated circuit. You just, as of now, remember that these 2 are serial communication standards that will help you or help the microcontroller to communicate with any external device. Similarly, Uart is another serial communication device which is again requiring 2 wires. Both Uart, SPI, and I2C are 3 serial communication standards in which the data is transmitted only 1 data at a time, 1 bit at a time. Okay. Finally, this device has a maximum oscillator support of up to 20 megahertz. This defines the speed of operation. So we have a maximum frequency of the speed is 20 megahertz. For our case, we have used only 16 megahertz in the board. So this defines what is the speed at which the board works or the microcontroller works. So that is important to understand as far as this microcontroller is concerned. Majority of the specifications are transformed into the specifications of Arduino board itself, because the board, the features of the board is decided and dictated by the features of the microcontroller. What is the feature of the microcontroller? Get transformed into the feature of the the board itself. Just like the characteristic feature of a father of a family represents the family itself. Okay, because he is the head of the family, he is the person in charge of a family. So his characteristic feature reflects the characteristic feature of the family itself. Similarly, for this board, who is the centralized device that defines the characteristic feature of this entire board? It is this device, microcontroller device. So that is why majority of the specifications of the board is dictated by the characteristic feature of this device itself. Okay, so that's what it is. I think I stop here today. Let us spend some time on understanding the features of the I/O pins and the rest of the peripheral features of this particular board in the next class. With that, I'll conclude the hardware component of that. After that, we'll move on to the explaining the software part of how to give instructions for this board and take it forward. So in today's class, we discussed some of the important features of this particular board. We understood what is Arduino. Arduino is a open source platform. Open source means it is license free. I need not have to pay any license fee for anybody in order to use the design of the board. So it is an open source hardware and software platform used for designing rapid products or rapid projects if you are a hobbyist. Okay. This particular platform has two components. One is a hardware component, which is nothing but the Arduino board. The other one is a software component. That software is used for providing instructions to this board. So using these two components, we can build rapid products or rapid projects. That is Arduino. Inside the Arduino, we have, to the context of this subject, we first learn how to use this particular development board. Later on, we will see how to design one on our own. That is also possible. I will teach you how to do that later on. But our first scenario is how to design, how to use this board. When somebody, as an engineer, when you get a bike, the first job as an enthusiast, as a person with a lot of passion in riding a bike is to take the bike and then start using the bike. So it is also possible for you to design your own bike and do some changes on that. That comes later on. But then your natural intention would be to use the bike and get used to it. So similarly, this is a bike which you should first learn how to use it and then take control over it, and later on see how to design something on our own. So the first discussion about this board started with the feature of a microcontroller. The microcontroller that is sitting inside this board is a powerful slave. This Arduino board is similar to an Aladdin's magic lamp. So the moment I rub this Aladdin's magic lamp, a powerful genie will come out. It will ask for a request from you, and it will fulfill that request. This is the process. This Arduino board is similar to a Aladdin's magic lamp. Who is the genie? The microcontroller in the board is the genie. When this genie will come out, don't rub this board. If you rub this board, only blood will come out from your hand. You have to connect this board to your power supply and activate this board. That is what we mean by rubbing the lamp. So once you activate the board by connecting it to the power supply, the genie will become active. Once the genie becomes active, it is a matter of giving commands to the genie. That is where a big problem comes. What is that problem? The genie unfortunately cannot understand my natural language. It can neither understand English nor understand Tamil. So I have to find out the language that the genie is comfortable with, which is unfortunately zeros and ones. So I have to find a middleman who can translate my instructions and give the instructions that the genie can understand, which is zeros and ones. Such a middleman is called a compiler. The compiler is a software which takes the inputs in the form of natural language that you develop the code, which is most likely any programming language, and then convert that into a format of zeros and ones that the genie can understand. So the three important concepts that you have to understand when it comes to controlling a slave device. Number one, slave devices are more powerful, extremely powerful. So our microcontroller is similarly a very, very, very powerful IC. Number two, it cannot do things on its own. It is very dummy, or it cannot think on its own. Similarly, our microcontroller cannot do things on its own. You have to define the functionality. Third point, it understands only binary language. So I have to find a way of communicating my ideas and thoughts to that IC by virtue of developing a source code and then convert it into a binary code by using a compiler. So that is something that you have to understand. So we went deeper into understanding our microcontroller. We saw what a microcontroller is. A microcontroller is a programmable IC. What is the difference of a programmable IC over fixed function IC? Fixed function IC means an IC which always do only one job throughout its lifetime. I gave you a small example of a NAND gate. A NAND gate always do only NAND operation, no other operation other than that. Whereas our microcontroller is a programmable IC. Programmable IC means I can change the function of that IC by changing the program. Today I run something, tomorrow I can run something else. So what is the exact name of the IC which I am using? ATMEGA328 microcontroller. ATMEGA328 microcontroller is manufactured by which manufacturer? It is manufactured by Atmel. Atmel is an electronic company. How do I know that? I know that because I get this information from the data sheet of the microcontroller. If you take any microcontroller, you can download the data sheet of the microcontroller. The data sheet completes data sheet of a microcontroller is just like horoscope. horoscope of an individual. You, Mr. Kumar is there. Mr. Kumar, when did he, what is the birth date, in which time he was born, what is his strength, and what are the position of the stars. All those information you know about that particular individual by seeing his horoscope. Similarly, any microcontroller, if you take the complete information of this particular microcontroller is available in the data sheet. So this data sheet contains the complete technical details of this particular IC. So this is available in the manufacturer's website. You can download from this and then you can understand what exact details that this particular device has. So any device, if you take that device, will have a data sheet. That data sheet will give you the complete information about it. So, for example, this particular IC is available in different packages. The package that we are going to use for our application is the DIP package, the one that is represented on the right, which is a 28 pin package, in which 14 pins are available in the left and another 14 pins are available in the right. So this complete information you get from the data sheet. Okay, so package means what is the physical shape of the IC. We saw two packages today. DIP package. DIP means dual inline package. I will write it here. DIP means dual inline package. Dual inline means you have two lines, one line, two line. That's what it is, dual line. QFP means quad flat package. QFP packages we use whenever we are designing small sized PCBs and boards when size matters. DIP packages are always bulky in size. QFP packages are extremely small and thin, so which will allow you to design very thin PCBs. All PCBs that are sitting inside your mobile phone are QFP based ICs, very extremely thin ICs. If you use DIP ICs in your mobile phone, then you will have a brick size mobile phones, like your old Nokia mobile phones. So the size of the package matters. Depending upon the project requirement, you use appropriate package, but eventually functionality wise, both of them are same. And we saw the features of ATMEGA328 microcontroller. How many pins are available? What is the ROM size? What is the RAM size? What is the EEPROM size? How many number of IO pins are available? How many timers are available? How many A to D converters are available? What is pulse width modulation? We will discuss later on, but there are 6 pulse width modulation channels available. There is one real-time clock available, which will enable you to find out real-time values of the time. And there are 3 serial communication standards available. One is Uart, the other one is SPI, and the other one is I2C. All the 3 are same, but protocol-wise, there are slightly different in this. All the 3 protocols will enable the microcontroller to talk to any communication, any peripheral device via serial mode. By using only 2 wires, it can communicate with an external device. Using one wire, the data is transmitted out of the IC. Using the other pin, it receives the data from the external device. So that is one thing. And the maximum speed that this particular device supports is 20 megahertz, but we are using only 16 in our case. So we'll see the further details about this particular Arduino board in the next class, and we will conclude the hardware features of it. And after that, we'll go about in taking control over this board by developing software part of it. Okay. So with that, I stop today's class.